All right, welcome back to the Micro Frontends Conference 2024, and welcome back after the lunch panel. Hope you had the opportunity to stop by the lunch panel and had a good lunch break as well, or another break, depending on the time zone you're currently in. I'm very excited to introduce two speakers from Zeiss Digital Innovation to the stage now, Stefan Bley and Braeschke. Welcome. Stefan Bley is a software architect at Zeiss Digital Innovation in Berlin, and Braeschke is a full-stack developer also at Zeiss Digital Innovation in Berlin. And they have both worked quite intensively with Angular already, and also have gained a lot of practical experience already with Micro Frontends and the Pyro framework at Zeiss in the area of performant healthcare digitization. And today, we will learn from them about a fundamental topic of Micro Frontends, namely how to manage dependencies in your Micro Frontends project, maintaining consistency and reduce loading times in such a project. It was actually also a topic that came up during the lunch panel, so I'm very excited about this now. They will also discuss the challenges that go along with sharing dependencies and how to overcome them, and introduce their process to ensure a collaborative effort between all Micro Frontends. Very excited now to basically introduce the title of this talk. It's Hitchhiker's Guide to Dependency Management in Micro Frontends, and the stage is all yours, Stefan and Lukas.
Yeah, thank you, Felix. I hope you can all hear me well. You've already introduced us, so I can maybe skip our introduction, except of the fact that Lukas is in Dresden. But we do Micro Frontends in the healthcare industry, and we have, before we ventured in the Micro Frontends, we had a strong focus on Angular frontends. I would like to first give you the context of what we will be talking about today. So we are in healthcare, as I said, and we help creating a software solution that helps medical staff in their daily work with patients. And depending on the nature of the features in this solution, or let's call them modules, they can be classified as medical products. And when you are a medical product, this means that you have very high quality standards, because this is a product that involves patients, real patients. High quality standards and also regulatory requirements. And this usually goes along with very complex and time-consuming processes, including documentation and verification by the legal bodies. So we want to keep these processes to a minimum. They can take weeks or even months. So if you have one change in a part of this solution, it should not slow down the rest of the solution. And that's why we decided to modularize the solution using a micro frontend architecture. While we wanted to provide a good user experience, having an integrated solution, we, for example, also including single sign-on, custom look and feel, common look and feel, we modularized the solution, which enabled us to have independent release cycles of these apps. And the sub-application can be owned and developed by different teams. And to still have this integrated solution, we also needed to enable the applications to integrate with each other, to have this seamless experience for the user. And there's an extra requirement given by the nature of these independent teams, which are also sometimes of different companies. We had to allow for different technologies. Now, so this is all cool. This is a funny project. We have a micro frontend architecture. The apps can use their own technology and dependencies. We also even share some dependencies because we are kind people in the app shell team. So what could possibly happen? I will present you one worst case scenario that actually happened to us. And this is when we first wanted to update Angular to the next version. And by the way, we shared Angular to all the micro frontends. So we say we want to update to Angular 17. And Lucas, can you please click? And the first app says, yeah, that's cool. We also want to update. We need the new features. And the second app says, no, we won't update our app to newest Angular because we are even out of maintenance. We can't develop anymore. We can deploy a new version. So what we eventually had to decide is to deactivate this second app from the productive system in order for the others to still run. Okay, so this talk is about dependency management. So let's look into what dependencies are. And first into the question why we would want to share dependencies. There are a couple of reasons. And the first one is for performance. If you go on, please. So performance, I think is obvious. We want to reduce the bundle sizes and we want to decrease the loading times to enhance the user experience. For example, if you consider the Angular framework with a megabyte or a UI library with fonts and images and all this, which in our case could be 5 megabytes, you don't want 10 or more microfrontends to bring this all along with them. Second reason to share dependencies would be consistency. We want to ensure a consistent look and feel by providing component libraries, for example, and also enforce compliant versions. Compliant meaning compliant with the current UI design, so we don't have any outdated design. And we also want to enforce consistent functionality, for example, by providing a certain version of a library that has the functionality that we expect and not something outdated. Third reason to share dependencies is to prevent runtime errors with libraries that cannot be used in different versions at the same time. In this example here, we see a runtime error from PDF.js, which cannot be used in multiple instances at the same time. And it will just error out at runtime. And lastly, we have security as a reason. Imagine there is a security vulnerability in Angular 17, for example, which has been fixed in 17.03. And wouldn't it be good if we can just provide that fixed version to the micro frontends, although they have been built with 7.00, so that they can benefit from this security fix and don't need to roll out their app again. Okay, so now that we know why we would want to share dependencies, let's have a look into the types of dependencies. And I've clustered them here into 3 groups. The first one is what I call the easy group. These are small dependencies. They don't have any global variables and no other dependencies. And they usually don't need any special consideration in the micro frontend setup. 2 examples here would be RxJS or Lodash. Then the second category is what I call the tricky ones. They are larger. They might have global variables and incompatible API. If we, for example, consider Angular, it is quite large. It also brings dependencies like RxJS, or even teams use NGRX, and this we also see this as a transitive dependency then, which needs to be considered. Angular also brings Stone.js, which creates problems on its own. It has global variables, like zone variable, also on current. And different versions have incompatible APIs. And it is unpredictable which version will be used in a given context, which then can lead to inconsistent behavior. And the third group is the very hard ones, which are just not made to coexist. One example would be web components. It was already discussed before that only one version of a custom element can be registered with the DOM at the time. And there may also arise style conflicts when they define different styles for the same custom element. You don't know what you get. And the second example I already teased is PDF.js. This library registers service workers to cache PDF files and improve performance. And in order to prevent multiple versions of PDF.js to register new service workers with different behavior, PDF.js JS itself does not allow multiple versions and then errors out at runtime. And with that, I hand over to Lucas to present us common use cases in Micro Frontends.
Yeah. Hello, everybody. Also, welcome from my side. Great to be here. Yeah, now we know what we want to share and why we want to share things. And now let's have a little bit a look at the how and we can share these dependencies. But before we do this, let's have a look at the use cases our solution has to support. So the first one is that we want to use here different versions. This could mean on the one hand side, something like we want to use Angular in version 16 or 17 in parallel, for example. But also, like we have seen an example at the beginning, maybe it's important to be here backward compatibility. Could be very important if we, for example, share your Angular as an app shell and we move on to the newest Angular version, that an old micro frontend still is able to operate. Also important, like we have seen, for example, with PDF.js, that we might have some dependencies which should only be there once. So we need to ensure that this is only existing once and only is loaded once. Also, a common use case which we have in our project at least is that some micro frontends want to share a dependency from their own. Let's say we have two micro frontends here who both use something like a whiteboard, have a library for that, and they don't want that this dependencies may be very huge, so they don't want that this is loaded twice, and they want to share this on their own. But actually, this is not the concern of the app shell to provide this library. So use case could be that they also want to share this by themselves with their other micro frontend, for example. And last but not least, what we have also already mentioned is this security issues. So let's say there's a vulnerability in one of the libraries, and it could be important that we update these. And this would mean that we would try to force an update here to maybe the next minor version or the next patch version, if possible. All right, with that, let's have then look at the actual solutions. And some quite common approaches are listed here. So one is the universal module definition. We have module federation, which I was also talked quite a lot about this here today, import maps, and system.js. In general, I try to give you now an overview about these solutions and will not go that much into details here because actually to all of them, you could do an own presentation on your own. So then let's get started with UMD here. UMD is a module format actually from the dark old days where you had actually some problems to use the same library in the front end as well as the back end. And consists mainly of two functionalities here. The first one is on top, where we actually in the end define the context in which the library is used or the dependency. And the second one is the actual implementation of the module itself. So what happens on top? Root and factory is used, to distinguish or to figure out in which context the dependency is running. So first check is actually if this is an AMD context. Second one is then checked if this is a common JS context. And last but not least, it's then expected that the dependency is used in the browser. In all three calls in the end, AXJS is used as a dependency, and in all three, it's actually expected that AXJS is already loaded. The second part is then the call of the function itself. So what happens here is there's first of all a check if self or this is defined. And then we have in the end our factory, our function here. And here you could in the end implement your own code. You can export things via the exports, and you could also use AXJS here as a dependency. The final result, if you would then call this module, for example, in the browser, would be something like window.mymodule.action, and then I could call this function. So this is an example how this could look like if you use this then here in your index.html or something like that. If you have script tag, which loads AXJS from a content delivery network, And after the UMD module is in the end loaded, you can see that we can use then ArcGIS here via the window. And yeah, we have then completely access to all of their provided library functionality in the library. So then what I personally like really about UMD is the simple setup. We used this once in one of our prototypes and it was actually quite easy. So we get started with UMD as we approach Micro Frontends since then. But at least on my point of view, I personally would not use this today anymore because there are other solutions out there. And in general, UMD is quite outdated. It's not that new anymore. We have now E6 modules, which I personally would, of course, prefer here. But it has also other downsides. For example, UMD could have sometimes some problems with naming collisions. If the imported dependency has a different name than the file itself, there could be issues sometimes. And also this resolving of the dependencies. The example which you have seen before will work definitely, but we are talking here about dynamically load and unload micro frontends. So there could be maybe some conflicts here that maybe your ArcGIS library is not loaded yet, and then you access the window object, but ArcGIS is not there. So there could be some issues. So yeah, UMD could be in some situations quite somehow tricky, and there could be race conditions. It works definitely, but you have to be a little bit careful. Okay, then let's have a look at something maybe more modern. And we have talked today quite a lot about that. So once again, I will not go that much into details, but there's of course module federation. And this is an example here, how this looks like for the webpack configuration. So we initialize a new module federation plugin. This has a name. You can have a file name which should be exported. You can expose here your components. But what we, of course, are interested in is here this shared entry. In this example, we have here ArcGIS. And module federation provides actually quite a lot of possibilities which you can configure here. For example, we have here eager true. This means that this library has to be there if the module is initialized. Singleton means this dependency should be only there once. And also we have this required version here. This follows the same notation like NPM does. So in this case, every 7.8 version would be fine. And the patch version would be ignored in the end and would just use the highest one, or the one which is provided by the app shell, to be more precise. What we have to see this in one of the other presentations today. The result would be that ArcGIS would be a separate bundle. So it would not be bundled as part of the module one, but it would be separated and could be loaded if required. So it's some form of a fallback here already. So in the shell itself, it looks quite similar. Also here, we initialize our module federation plugin. We have here as well a name. And what is here, of course, important is which dependencies should be shared from the shell itself. So then let's have a look at the code itself. If you use this plugin, you have access to certain methods. The first one is here in the first line, this webpack init sharing. What it does is it initializes a new list of shared dependencies based on the configuration in the initial module federation plugin. Then we create a script, load our module, append this to the DOM, and after this is loaded, module one will be available in the window object. What is then missing is that we need to initialize this module. And for that, we actually need to provide here our list of shared dependencies. And then the module in the end will check, okay, which dependencies does the shell provide? Which one can I use? For which one I have to use my own fallback? But also it will enrich this list of shared dependencies with its own dependencies. So let's say the module will provide here, for example, Lodash. Then it would be added as well to this list of shared dependencies. And another micro frontend could then reuse these dependencies as well and does not have to provide its own. Yeah. In the end, modification is very mighty. There's a reason why we talk about this that much. It not only provides you, of course, utility to share dependencies, but in general, it's a very solid solution. What I personally like quite a lot about this is this version resolution, which is already here built into this approach. So we don't have to care about anything. It is all happening at runtime. We don't have to write here our own meta system or something like that. It's all included here. And of course, we also don't have to care here about resolving of dependencies. This is all done by the plugin in the end. So we don't have to care that everything is loaded or something like that. This is all done here by the framework. Only downside here is that we are bound to Webpack, which is of course a risk you might want to take, but still, at least from my point of view, this is a downside if you are bound here to one certain bundler. There are maybe faster bundler out there which you might want to use, so then you are here somehow limited. Okay, with that, then let's have a look at the more agnostic approach. I'm talking about import maps. Import maps is an standard of the browsers, which most of them supports today. And it's actually quite simple. You have one script tag with a type import map with a JSON structure. And the most important property is imports, where you can specify where your dependencies are available under which domain or which URL in the end. For example, I provide here an approach how you could use AXJS in parallel in version 6 and version 7. In this case, we load them from a CDN, but in theory, you could use here also your local domain or I don't know, something else. And if I want to use them, it's also quite trivial. I just have here my ES6 module, and I can use my ES6 imports to just use these dependencies. And of course, they are not resolved if the import map is loaded, but only if they are used. So I only load those dependencies which I also need. And then I can just use them in my code like I'm used to. So a little downside is here, of course, the browsers, which supports import maps. All new browsers actually support them, like we can see here. But for example, the old Edge is not supported, or the Safari 15 is not here. And of course, something like Internet Explorer or something like that will also not work. So personally, once again, what I like about this is this is native browser functionality that I can use my pure E6 imports, and this resolving of dependencies is all done by this ES6 modules. And once again, I don't have to care here about anything. Downside is that there can only be one import map. So let's say I load my micro frontend, then it not can just add its own dependencies to this import maps. They all have to be defined before we use this. So at the start of the application, if we fetch the application in the end. So I really need here a central register for my dependencies. Also, browser support is somehow an issue. Like I said, new browsers are supported, but if you have to support some legacy browsers, you could run into some troubles here. With that, let's have a look at System.js, who somehow tries to solve this gap. System.js is also a form of module. Every modern bundler is able to produce this. And in order to use this, you need a library as well, the System.js library, which needs to be initialized once. Afterwards, the system is then globally available, and you have this .register functionality. And the two important properties here are this array at the start and the factory here as well. In the array, we can, in the end, also, similar to UMD, somehow define here which these dependencies we need. And this factory needs to return an object with setters and execute. These setters are invoked in the same order like our array at the start. So right now we have here only AXJS, but let's say we would have Lodash, then there should be a second setter, and the first setter would be called for AXJS, and the second setter in the setters array would be called for Lodash. Then we have here our execute property, which will invoke if our module gets loaded. In the end, once again, similar to UMD, we can in the end define here our module, we can write our code, and we can use this underscore export notation to export anything we like. System.js also supports import maps, so we can then use also import maps here on all the browsers. In this case, we have one that's again our XJS example. So yeah, System.js provides actually everything, at least from my point of view, that import maps already provide, but of course, it will fill here the gaps. So in theory, you can use this System.js also, of course, in your backend, but also in the Internet Explorer if you like. It's backwards compatible, and I personally also really like that you can use here almost the same semantic as we can use for our E6 modules. Own real downside is have here additional dependency. So System.js needs to be there, and sometimes there could be some little quirks, but in general, it's of course working wonderful, and I can really recommend this. So besides our technology approach, we have also some other things that we do as an app shell team. And what is there the most important thing is, of course, this to ensure this backwards compatibility, that something like we have actually described in our worst case scenario at the beginning will never happen. For that, all modules, all microfrontends should be self-contained and not be dependent on any external dependencies, because they could change for some reasons or the other. One of our key tasks is here, of course, to facilitate between the teams, support them to implement their business use cases, and also, of course, the coordination. Especially if you're talking about major updates, this needs to be coordinated. We need to all be aligned, and we should also, of course, try to target here the same version. It really does not make sense if every microfrontend provides here its own Angular. So something we do is we establish target versions for our releases. It could look something like this. We are talking about now 1.2, 1.3, 2.0, and they don't match with the dependencies. But what we do is we say, okay, in version 1.2, we use AXJS in version 6.6. In version 1.3, we use version 7.5. And we do this because we have these long release cycles. So microfrontend teams need really time to adapt here. They need to be aligned. We're talking here about quite a lot of people, quite a lot of microfrontends, and all of them need to plan this effort. Especially a major update is, of course, not something you can do in some cases on an afternoon. Sometimes you need to really spend effort here to make this work. So for us, this is one of our main responsibilities, that everybody is aiming here for the same versions to decrease the bundle size as best as we can. With that, I will hand over once again to Stefan.
Yeah, thank you, Lucas. And I will give a short summary of what we have achieved in our project. So we managed to create a micro frontend architecture in a healthcare setting with all the requirements that come with it. With single page application composition, currently supporting Angular and React as frontend frameworks. And we integrate currently more than 12 micro frontends from individual teams with different technologies and also around the world, the teams being located. And the number of these micro frontends is still rising. As we have learned, dependency management is a challenging thing. There are important reasons to share dependencies or enforce equal versions, as we've learned, and at the same time also allow the feature teams as much freedom as possible. You always need a solid concept that includes clear processes, for example, for the version updates, as Lucas explained, the focus on backward compatibility, thorough documentation, and also you need to foster a communication between all the teams involved. I think we have come up with such a concept, but we haven't solved all our challenges yet, which leads us to the outlook, what we can improve. And there I want to highlight two things. One would be better tooling. So we can imagine that we provide some linting where we display conflicting versions of libraries before runtime. So it might be at build time or at the deploy time when they upload their pilots. And the second thing, which was actually already mentioned in the panel talk at lunchtime, is about web components. There we still have this limitation of custom elements, which can be registered only once in the DOM. And as you know, there is the scope custom element registry proposal out there, which would then help to create multiple registries, which can then be attached to shadow DOMs and which would then resolve the problem for web components. We're currently looking into these two things, also others, but these have our main focus. And yeah, I think we are on a good track. With that being said, I thank you for your attention. And if you have questions, please go ahead.
Thank you so much, Stefan and Lucas, for this very informative talk, breaking down all the different ways to share dependencies in the context of micro frontends. Great stuff. There was also like a lot of comments coming up in the section, and I will just choose one of them. The first one was from Denislava. She was asking, what framework are you actually using for micro frontends applications with Angular? Maybe you can also like elaborate a little bit on that, why you chose it.
And now if you have seen the commercial, but we're using actually Pyrrole here. And it actually helps us quite a lot to facilitate this. Provides already quite a lot of utilities. Also has its own notation to set up these import maps. But they were, especially with Angular, we had recently an issue, for example, where it was quite hard to use here Angular 17 and 16 in parallel because they mess up with, they have a property in the window object, and then Pyrrole has already resolved this, so this is already fixed. But yeah, we had quite a lot of, or not quite a lot, but we had some problems. It was actually not that simple as we had expected, but this was not, was more a problem how Angular works than Pyrrole.
Right, it's not really designed for micro frontends, as we already learned.
Yeah.
Just have to find a way to make it work. Next question was from Twine. What is the role of npm packages in micro frontends? Maybe like
I don't get the question 100%.
Yeah.
So of course we use these. If we talk about our micro frontends, we mostly we're just talking about here npm dependencies which we use and which we would like to share. And then of course what we want to do is that we try to use here the versions from npm as well to identify which version we want to use. Just in general, I would say the role of npm packages for us, the main source for dependencies.
Great. And next one from Robson. How do you prevent version conflicts of a dependency using presented methods? How can I use, for example, multiple ArcGIS versions using import maps?
Yeah, I can skip back and show this. So in general, ArcGIS is actually not big of a deal. What you actually need to do here is what, for example, Pyrrole does. It provides its own meta framework in addition to these import maps. So Pyrrole has their system on their own. If you want to just go pure, you of course have to think about notation in your team which you would like to use. Okay, this is not system.js, but it's the same notation. But for example, this example here, it's ArcGIS at 6.x to use the 6 version and ArcGIS 7.x to use the 7.8 version. If we have, for example, it depends which only could be used once, let's say Zone.js or maybe PDF.js, then you should maybe make sure that this is just named once in your import map, and all micro frontends are only allowed to use this dependency in your via the import map and not bundle this by their own. And of course, this is what Stefan also said in the end. For this, you need maybe some tooling, some custom linting or something like that to enforce this, because otherwise there could be then issues at runtime. And if we are talking here about maybe dynamic micro frontends, which are not always there at the time, it could be also quite hard to test them. So I would definitely go here then also maybe for an build time check if these rules are used correct.
More and more questions coming in now while we're answering the other ones. I think we still have enough time. For example, this one, how do you manage the upgrade of one runtime only dependencies like Angular React across all the micro frontends?
Yeah, so also about it, we talked already. So what we are aiming for is to have a short period where we actually want to use both in parallel. So it should be possible that, for example, use an Angular in version 16 and 17, because in our process, it's really hard for teams or even to make a hotfix. This is already quite expensive because you have to provide there's this regulatory process which you need to fulfill. You need to provide documentation and things like that. There's, of course, QA you have to pass, system verification, and so on. So what we're aiming here for is to have them both in parallel, at least a short amount of time, and then until all teams in the end have used then the latest version, and then and all of this should be, of course, dynamic and be in a way to do not have this issue we mentioned at the beginning, that you have one time you have a microfrontend which just does not work anymore because it was dependent on the old version. This should, of course, never happen. So because of that, we need these two dependencies in parallel.
Makes sense. Thank you so much. I think one more. Let's go with this one. What is your vision on share scope in micro frontends? So module federation, I guess we can manage versions even though it is singleton. I don't know if you heard of that.
Can you repeat the question, please?
What is your vision on share scope in micro frontends? As far as I know, with share scope and module federation, I guess we can manage versions even though it is singleton.
I don't get the
Maybe,
question.
maybe.
I don't know the share
can
scope feature.
elaborate a little bit more. Yeah.
Okay, maybe you can also just chat then afterwards.
Yeah, like just answer in the YouTube section, in the comment section, right? I have one more from Greg, maybe this one. From styling perspective, you mentioned component library. Do you have separate team to manage component libraries in a storybook, or do you use third-party libraries?
Yes, so we have a dedicated team in Zeiss that creates this component library using web components. We also provide a React wrapper, and this is used across Zeiss. And maybe to also answer another question in the chat I saw about prefixing the custom elements with numbers or something else. We also went down this road now for a first solution to have multiple instances of this web component library used at the same time. It helps, but it is not the ultimate solution. So custom scope registries would be much better.